Hello, good evening. I'm reflecting on many of the issues that we've discussed during this conference, and I'd like to thank Alexander for his kind of aspects of what a thinking curriculum should have in his presentation, and I'm going to use his 4 ideas, looking at scope, learning outcomes, progression, models, and assessment, to look back at a thinking curriculum that I developed with colleagues in grade 5 and grade 6, 7 and 8 in an international school in Zurich. This was based on training in Let's Think English that the 5th grade and 6th grade English teachers and class teachers were having, and also working with them on some epistemic inquiry units and using case lessons with the specialist science teachers in grade 6, 7 and 8. And so I'm going to apply these 4 requirements to what we built and look at the aspects in relation to the use of case and epistemic inquiry in the building of a thinking curriculum. First of all, some brief introduction for those that are not familiar. CASE is Cognitive Acceleration Through Science Education. You could just see it as being 30 intervention lessons, which is some people's experience of it. And by intervention, the idea is that it's not trying to teach any particular curriculum. The lessons are designed to actually intervene in the development of formal operational thinking, as described by Piaget. And so it's a thinking intervention set of lessons that stands outside of the curriculum and is traditionally been done in the first 2 years of secondary schooling, grade 6 and grade 7. However, it's more than just these lessons. These lessons are kind of the instruments or tools that have been created from the cognitive readiness and demand theory that Michael Scher and Philip Adey and many others developed over decades. And this led to the whole case concept. An important thing they developed based on Piaget is scientific reasoning tasks, science reasoning tasks, SRTs, which are a group task that a teacher can do with a class based on the clinical interviews that Piaget had developed, and they create these, and I've used them with many thousands of students, and they give great insights into the cognitive readiness of students. Also, they developed a curriculum analysis taxonomy that enables teachers to collaboratively understand the thinking demands of major items of the curriculum. Here's just one example from thermal physics. And the idea is here, the scope of the type of thinking demands that are needed in relation to content and conceptual items from the curriculum have been fully described for all the aspects of the traditional lower secondary to high school science curriculum. In developing these, they did a huge survey of UK students, 11,000 students, and found that, different to the predictions of Piaget, that most students did not reach formal operational thinking by 16, and that when you look at traditional science and mathematics curricula from 14 onwards, high school curriculum we would call them in the US, or late secondary in the UK, or grades 9 and 10 in international systems, that there's a gap between the abstract formal operational thinking demands of the curriculum and the readiness of students. So, in summary, CASE is the lessons, instruments to measure cognitive readiness and cognitive demand, and also a professional development program, which is a form of kind of cognitive apprenticeship for teachers. So, how does this get applied? talking of scope, we have the formal operational schemata as described by Piaget across the bottom, and the lessons are designed to have an access level that fundamentally all students in these age range should be able to access. They have a central target and also some higher level possibilities. So instead of them being a particular learning outcome, they're a targeted intervention to introduce students to these schemata, and so they're designed to interfere with the normal development and accelerate it, with the idea that there's a lot of research shows that the development of Piagetian competencies, formal operational thinking, are highly correlated with educational success. So how is this used, this progression model that we have of lessons that start at a lower level, target a central level, and try to stretch beyond in terms of cognitive demand? Teachers and students will be familiar with these lessons by the end of year 7. And so I worked with teachers in what's called year 9 in the UK or grade 8 in the international system with the concept of equilibrium, the schemata of equilibrium, which in the case lessons, these are the two, lesson 28 and 30, are about physical equilibrium systems. And in each of them, there are 4 variables at work, which makes them fairly complex and high order and demanding. In lesson 28, uphill and down dale, we have the angle of the tracks and the masses of the vehicles involved, and a whole exploration of how to reach an equilibrium point. Similarly, the last lesson, 30, is a complex lever balance where we have distances on the left and the right and changing masses on the left and the right and looking at rules of equilibrium. I worked together with the teachers to design in the thermal physics and heat transfer topic that is one of the first in grade 8, how they could use these schemata and generalize them into new ideas of thermal equilibrium. Again, we start with a quite simple thing where there's only equal masses and different temperatures, so the multivariate nature is kept simple to begin with, and then as we go through the episodes of these lessons, mixing water of different masses or volumes and different temperatures. And throughout, we use the predict, explain, observe, and re-explain strategy. And also the 5 pillars are used throughout these experiments. That's an example of how working with teachers who are familiar with the case lessons, they've served kind of their cognitive apprenticeship, to be able to plan how to apply to other parts of the curriculum and how to move beyond the specific application of equilibrium, in this case, to a more wider concept of equilibrium. Of course, this is demanding a generalizing of thinking strategies. That was previously a movement on beyond case. This is where actually case is used as almost a framework, a progression model, where the case lessons are done once a week, and they set an agenda for an epistemic inquiry lesson at the start of each of the units. These units are not all epistemic inquiry lessons and case lessons, but that's how they start. We have a case lesson followed by an epistemic inquiry lesson that's designed with exactly the same thinking schemata, but now put into the topic units with the content and knowledge that we need to develop. Each of these units through the year moves from quite concrete preparational work to become more advanced and to stretch as the students are developing their thinking skills in a new context and often with a new thinking schemata. So the idea is kind of the backbone of this sixth grade curriculum is case lessons, epistemic inquiry lessons that have been bridged from them. And then the context is a normal kind of unit. We talked about scope, the scope of trying to push the thinking schemata, trying to push the epistemic language involved. And this was something that was the kind of epistemic language used by the teachers in primary school. They'd been trained in Let's Think English, and I'd trained them in the Let's Think Science way of working. And I wrote the lessons for them for an energy unit. And then the grade 6 science teachers and I had worked together, but similarly, the 6th grade English teachers were continuing. Now, this is the first sets of results that we got over 2 years. The red line is our 5th grade students at the start with a Piagetian measure to the end of 5th grade and then the end of 6th grade. So we were measuring their Piagetian levels with the science reasoning tasks compared to the mean of the huge cohort that Shea and Adi and their workers had got from the UK. And we can see evidence within the Piagetian framework. Now, some would say, well, okay, they've been taught in a Piagetian program. You would expect that the reasoning measurements of the Piagetian interviews turned into tasks might be suspect. Well, as in all of cognitive acceleration, we also looked at some kind of assessment of more generalized competencies beyond the immediate context of learning in science or learning in English. The school regularly did what's called the Australian Council of Educational Research tests, ACER tests, which are based on the psychometrics of PISA tests, but they're done from grade 3 up to grade 10. And so we had a lot of our prior results, but also there was a big survey done by the IB where they looked at the top 14 schools in the IB that do the ACER tests, and we used them as the control group, which was a very, very rigorous control group of our 5th grade through to 6th grade students. And these are the effect size in terms of standard deviations that they've got in mathematical literacy, reading, narrative writing, and expository writing. But interestingly is we passed the data to look at the lowest quartile of our students, and there we see much, much bigger effects. What's really interesting is that our intervention was in Let's Think English and the use of case and epistemic inquiry lessons, and actually the mathematical literacy improvements are some of the largest. So that's an example of what we call far transfer. So going back to, was this a thinking curriculum? We defined our scope in terms of the Piagetian thinking schemata, which we considered highly relevant to the subjects we were doing it in. We also were interested in the growth of epistemic knowledge and language that the students would use. We gave them a lot of scaffolding in terms of argument, sentence starters, conjoining terms. For instance, this is like this, whereas that is like that. the kind of language of comparison and contrast, the language of deduction, the language of induction. So these two interventions, the science and the English, were actually really focused on the transferability of thinking language, which obviously then is a stimulus for metacognition. In some of our discussions, we had this idea of, well, the type of thinking curriculum problems, tasks, or tools that you would use. What were the criteria? And this is the conclusion that I came to, and it seems to be very similar to many of the other participants in the discussion. For instance, Anna and Alexander in our discussion yesterday, this idea of the need for contradiction and dissonance to be resolved. Christoph also came in with that idea that from a philosophical viewpoint, to make clear the problem, to problematize things that appear simple as a starting point for activating thinking. Looking towards tool development, as I hope I've explained before, the case lessons, the kind of PD, the professional development we do, can be seen as a cognitive apprenticeship for teachers to get them to be doing a lot of metacognition and thinking about their practice, their curriculum. And an important part is that we actually, during the PD, work as if we're a group of learners, where the Let's Think case trainers will lead a lesson, and it'll be simulated where the teachers are acting as learners, so they're experiencing metacognition and bridging. And we debrief to how these tools can be further developed, as I've shown, for instance, with the thermal equilibrium coming from the equilibrium case. So the idea is teachers are able to expand beyond the more scripted lessons. And the overall purpose of using these tools is, well, basically for this language and metacognition acquisition. Also, to make very clear about the possibilities to progress from domain specific to more domain general. And that was marked in this, that the English teachers who'd been trained in Let's Think English, as the primary teachers in particular, they have to teach maths and they also have to teach science in their IB units. And they all said this gave them a template for thinking about lesson planning beyond the Let's Think English or beyond the epistemic science inquiry lessons. And they said it became kind of part of their toolkit after 2 years. Okay, that's my reflections. Sorry I can't be there for the majority of the session. It's been great working with you guys.